Hello folks, welcome to another Sunday session. This one's scheduled just a tiny bit on short notice, which I apologize for, but nonetheless I wanted to throw one of these before it was time had passed too much, because I will not be able to do one of these for another four weeks. So just want to do a quick session today. I know not everyone may be here because I didn't give you a ton of notice, but let me know if you are here, and if you're going to catch up, I will give you the full rundown. So let's get my virtual window up here. Here we go. Alright, so what we were going to cover in this particular session in full, although I don't have it, was going to be what's called pre-training, which is where you teach a model its parameters for a large language model. It's the word that's being used, the pre being a little bit of a hint here about what's going to happen. And then the other was the rest of the training methods that are used to train these large language models. So if you remember when we went to basics, let's see what I have here. When we did the basics video, we set up a neural network. Let's see. Let's see if I can find it. Oh. Sorry about that window. All right, so in here, if you remember this notebook, we wrote a lot of code, and we provided we wrote a lot of neural network code, and we did the very classic thing where we had an X that was observed and a Y that was observed, and then we were estimating the parameters of that model. That's really what we're trying to do here with all of our models. What we have, whether it's a Bayesian model or a causal inference model, or even these large neural network models, is we have our observations. We have maybe some input data, which is typically called an X, and then we have this model where we're trying to estimate and learn all the parameters. Let's pull this back up. We then talked about large language or small language models. This was the last session, and in the small language models, what we wanted to do was take a sentence and have our model learn the probabilities of certain words. So in this case, we had these sentences, and we had the probability that is comes after name, or the probability that name comes after my. And so in a small language model, it's pretty easy. You take a bunch of strings, and then you see what happens. But what's something subtle here that I didn't cover in depth last time, but I want to bring up here, is that what's happening here is what's called self-supervised learning. We're not explicitly constructing a set of, we don't have a set of output data and a set of input data. What we have is the inputs and outputs together. So in this sentence, what we do is we take the word and we look ahead. We take this word and we look ahead, and we take this word and we look ahead. And that's the way we learn language. The training examples are constructed from the text corpus itself, which is super fascinating, actually. You don't have to see the classical output variable and input variable, or independent variable and dependent variable. The language corpus itself constructs these sets. So we take this and we scale this all the way up. That's what's happening in large language models. And so this is going to be our short session for today. We're going to talk about what's called pre-training. Now, I'll give you a quick sort of foreshadowing. Our goal here is to understand how these large language models like BARD or ChatGPT work. And the analogy we've been talking about is we started with bicycles, and these large language models, though, aren't bicycles. These large language models are entire enormous ecosystems of these enormous trucks, these massive semi-trucks. And as you know, with a semi-truck, it's not just one simple process to make it. It takes a whole bunch of stuff to get going. It's going to be the same thing with these large language models. while the intuition is very simple, it's actually exactly the same as the small language models that we covered last time. With large language models, it's going to be that plus a lot more. The first step being pre-training, but then there being a couple more steps that are taken to make these models work and behave the way they're going. So we're going to dive into that with training or pre-training, but let me first check the chat to see what's going on. Yuri says, hello, can listen live for about an hour. Well, we're going to try, this one's going to be much shorter than an hour today, Yuri. Because we'll talk about pre-training, and then I'm going to do a little bit of talking about where I'm going to be the next month or so before we get back into the book club. So to make sure I give you some technical content, what I've written here is an entire, a small summary on how pre-training works and how these models work. I'll talk through it quickly in about, let's say, 5 minutes, and then invite you to both read this and then run through the video on your own time. That's below. By the end of this, you'll have a really good understanding of, honestly, how these models are trained up to 90%. So how the first 90%, or let's say 95% of compute is done for these models to help them learn and understand and train the weights. And then I'll talk about the last 5% after. So the first thing I want to say is that what we're going to be, we'll talk through the intuition, and then I'm going to talk through the practicality. To give you the end at the beginning, the best single resource I found for this pre-training and understanding this is Andre Karpathy's Building a GPT from Scratch. And so if you want to learn this in depth, just go through this video. I'm going to provide a summary about what happens in this video again in the next couple of minutes. So the way these models work from training to text generation is they do a couple of things. Let's say we want to train a model on this particular text. This is me training a large language model to learn the phrase large language model. If you go to ChatGPT or Bard and you ask it a question, it very well can turn out this string, which is readable in English. It's perfectly grammatically correct. It gets the punctuation, and it sort of begs the question, how can you take something that's just millions of parameters, let's say, in some cases it seems now even billions of parameters, and get it to learn the association between words so that it is able to produce this output? Like, again, that is quite incredible that it is able to do that. It is very unlikely that a small language model would be able to produce such a long sentence easily. So last time we'd also talked about the mechanics of a transformer. We talked about attention and query and key and value. We talked about feed forward, but we didn't talk about how these particular parameters are trained. So the discrete steps for doing these things is first you take these words and then you convert them into a numerical representation. Because we're working with a model, a mathematical model, mathematical models can't operate on strings. They need to operate on numbers. So this particular step is called tokenization. It's turning these words into tokens. Now, the first deviation we'll take is that you can do this many ways. You can turn each individual letter into a token, into a number representation. You can turn entire words into tokens. That's another strategy. Or you can turn them, or there's sort of an intermediate strategy. In Arjun Karpathy's videos, he takes the simplest approach, which is just turning the individual characters into tokens using a Python dictionary. You'll see in this video, he's going to map A to 1, B to 2, C to 3, and then even the capitals will get their own letters. So then they'll be like A is 27, so on and so forth. And there's also, as you know, more tokens than just letters. There's colons and all sorts of things like that. So the reason, in his tutorial video, that's easy to make sense. In the real world, think about what that means. It means that if you have a sentence, the sentence could either turn into, we can break this up into an array that ends up having a mapping of 1 to every single letter and character, but we'll end up with a lot of characters, right? Like so many things and so many associations we need to learn. The other extreme is we could turn this we could turn the words into tokens, but there are a lot of words that mean similar things or could be about the same, or words that change meaning depending on what happens with a slight alteration in the word itself. So in practice, what tends to happen is this thing called a tokenizer. I've linked the OpenAI platform here, but know that when we go into large language model training, all of the production systems, they don't use word level or character level. They use a specific thing called a tokenizer, which figures out how to split things up. In this case, this is the GPT-3 tokenizer. So this is actually what is happening when you're talking to ChatGPT. Here, you can see for the most part, it uses words and this particular character and this comma right here. But if we take a more complex sentence, you can see things start to shift just a little bit. So in here, the G in GPT is its own token, and the PT is its own token. If I even put in more text, most of this looks like it's about tokenized, as we would expect, except for the GPT here. Let's put in this last thing here. All right, now you're seeing things that are subtly different. Here, the tokenizer splits the tilde and equal into its own. It splits this parentheses, but then this one and this parentheses and this period go together, as probably signifying the end of a sentence. Tick token is split into three different tokens, a T and IC a token, and token is its own word. And so it's not exactly character level, it's not exactly word level, but it's somewhere in between. And so going from a basic intuition of just the individual characters to maybe what we would think would be also intuitive, the full words, the first step is tokenizing and converting sentences into tokens through some let's say magical logic here. Now, if you're curious about the very, very internals of this, you can look at Google's tokenizer, which is called Sentence Piece. And so we won't go into the details of the tokenizer here, but this is suffice to say, the first thing we do when training large language models, or anybody does when training large language models, is convert a sentence into discrete numerical representations. And while there's a bunch of different strategies to do that, the main strategy that's used, or the actual strategy that's used for most large language models in production, is using a tokenizer. Now, one confusing thing that stuck me for a while, but I want to point out, is that they also use the word encode, in this case, to mean converting the string into a series of tokens. So if you recall, in a large language model, we have a thing called an encoder. It's the thing over here on the right, positional encoding, and there's this thing right here is called an encoder. And so the word encode gets used multiple times in different contexts, and it's a little confusing because you're reading about encoders, about transformers, but then you read about encoding in tokenizers, and then you also read about this thing called positional encoding, which is the relative position of words to each other. So in the literature, and even when listening to this stuff, just be careful when they say the word encode or encoder or positional encoding, that you understand the word encode in the context that it's supposed in context. As we're talking about large language models, this is what's confusing about languages, right? The same word can mean multiple things, and you need to have the context to understand it. So just like large language models have to understand that context, when you're learning, this is something that's been tripped me up a lot of times. This word encode being used in different ways, right next to each other in the same context. All right, so now we have step one done. We have taken our sentence and we've encoded it into a series of character level encodings, tokenizer encodings. We have essentially what ends up being an array. In the OpenAI tokenizer, if we took this particular phrase once again, and I want to show it to you so it's all above board. What we have, this is the text that gets highlighted and shows you what the tokens would be. What we end up with is this exact array. We have these tokens that are like 1012, 318, 3047, 3003, and this is just what happens to come out from the once the tokenizer encodes this string. So now we have an array, and this looks much more like something we could feed into a PyTorch or Flask or things like that. So how do we turn this array into actual training examples? Well, this strategy is called self-supervised learning, and then the particular strategy is called masking. What we can do is we can take slices of this array to predict the next token. So in this case, we take the first 4 tokens, and we say the prediction value should be the next one. We can then construct another training example where we take the first 5 tokens, and then we say predict the one after that. And then we take the first 6 tokens, and we predict the 7, so on and so forth. And you can see here how we're starting to construct a training set. And you can see, actually, interestingly enough, how easy it is to construct a training set. Because what we can do is we can take all sorts of text, whether it's books or the internet or anything else, and we can use that written text to then create a massive training set, which includes both the inputs and the outputs. Think about how this is fundamentally different than if we try to do image classification. If we're trying to do image classification, like the MNIST example that we first went through, you have to go through and you have to label every image by hand. Let me pull up the MNIST data example. So somebody has to go through and write down that this is a 0, and this is a 1, this is a 2, this is a 4. And people manually have to do this for the computer. It takes a long time. I mean, these image data sets take quite a while to build up. Not just the images themselves, but then the labels. But with language models, we can do what's, again, called self-supervised learning. We can computationally create the inputs and the outputs, the labels and the inputs, just by using some, essentially with some very basic for loops. This strategy is called masking. And what I've shown you here is predicting what's called the next value. But you can also use masking to say, let's take these tokens, and then we actually just wipe out this one in the middle, and we give the language model all of these tokens, say 1, 2, 3, 4, and then 6, 7, 8, and ask it to predict 5. You'll see some of the models are trained in this way, where what's masked is in the middle, but the idea is the same. We just take pieces of our tokens or our array, we blast out a piece, whether it's everything to the right or everything or things in the middle, and we ask the model to learn to fill in that gap that we've just given it. From there, it's just a standard estimating the weights like we've done in any other language model, any other model at all, Bayesian, causal, inference, whatever, asking it to determine the weights that'll help reduce the loss for predicting that missing token or predicting the next token in our training examples. And that's it. I mean, that is literally what it takes to train a language model at the basics. Again, invite you to go through Anjay's video where you'll see him write this out in full code. It feels deceivingly easy, I have to say. So now you may ask, what do we do? How do we generate predictions? And so this is the text generation portion. What you essentially do is you just give the language model a question. So in here we say, let's say we want to finish a sentence. The easier one is Romeo and. Most of us that have read a lot of plays or been exposed to English know the next word is probably Juliet. And because the language model has seen so many instances of Romeo and Juliet online, that is the next obvious token. But if we make a slightly more complex sentence, Romeo and Juliet in the play end up, we say what is in the end or what could happen in the end. And if you know the play again, they end up dying in the end. Sorry for the spoilers. But it's the same idea. Because the language model has seen so many associations between the words Romeo and Juliet, the word play, it can fill in the rest. In text generation, that's what's happening in the model. You're feeding in first the encoded query, you're handing that to the model, and you're asking it to predict the next token. Now, what the model does under the hood is it takes this string, it predicts the next token, then it uses the token after that to these sets of tokens to predict the next one, and so on and so forth, which is where the text generation portion comes into play. So intuitively, it's actually not too bad, and even programmatically, it's not too bad to implement. There are a number of challenges. So some of the challenges that you've probably heard about are hallucinations, which is the model, because it's just making predictions, can predict things that make no sense or are factually inaccurate because the model is not understanding. There's a little bit of debate about this, but the basic language models don't know facts or logic or theory. They just see associations of patterns and they try and make the next best pattern. But sometimes those patterns can deviate wildly. So just like in real life, when you're, say, rolling dice or flipping coins, you couldn't end up with a series of heads. It's unlikely, but it's possible. And these same things happen with language models. They could end up on a track that's just completely random and goes off the rails. But what's crazy is they do it in a way that honestly looks plausible, but it's factually false when you read it. Another thing which is challenging, and when we talk about AI alignment and more, say, philosophical topics, is with these large-scale language models, they're learning from whatever you're feeding into them. And because we're training them at scale, sometimes things can get put in there that, definitely things get put in that not everyone agrees with. So some of this could be things that are egregious that most 99% of people would disagree with, but one or two people wrote it, and so now it exists on the internet. So, but if you slide the scale a little bit, there are opinions that are held by larger subsets of folks, and not different groups of people don't agree with them. But because this is all going into the language model will have this all under the hood, let's say. However, there's a bunch of strategies to try and make things, let's say better. But what I would say for now is, or what I would say at this point is, this set of stages is what's called in the AI world is now it's called pre-training. And so it's a little bit of a misnomer because you're still training the model, so it's not clear where the word pre comes from. So it is training. But the reason it's called pre-training is that with most large language models, what's happening here is you're learning, let's say, 90%. You're getting 90% of the way there to a chat GPT or something like that. These pre-trained models learn the association between words. They learn what's going on in terms of grammatical structure and things like that. But they aren't useful in the sense that if you try and interact with them like a chat GPT and ask them a question, they just complete the sentence, which isn't the greatest. Or if you're trying to get them to be helpful or friendly, they really have just literally taken on the persona of the books or the internet they have read. So it's called pre-training because this is the biggest step and the first step before a bunch of other things happen. Now, another important point of why these are called pre-training is that in the biggest scenarios, like a chat GPT or Bard, this is the most expensive step. It takes a lot of time and computational energy to get to this point. So you don't want to be training these models over and over and over again, end to end, to create new products. What tends to happen is these models are trained and their weights are checkpointed, just like we did 2 sessions ago. They're saved in a particular state, and then you can decide to then alter the last bit of behavior from there. So this is where we're gonna pause this book club technically for now, but let me show you where we're gonna get to. There are a lot of things that happen after pre-training. So once pre-training happens, you'll hear words like supervised fine-tuning, reinforcement learning with human feedback, instruction tuning, reward model. These are all ways of taking a pre-trained model and adjusting it to work different ways. And all of the chatbots that you're going to use on from services like a ChatGPT or any of Google's products or Claude or Pi from Inflection AI, they've all gone through various rounds of these. The resource I'm going to provide you, but I'm just going to give it to you right now, is also this video from Andre Karpathy. It's when he about a month ago, so actually not too long ago, presented at the Microsoft Developer Conference, and he listed all out right here. I actually appreciate this video because if you watch his GPT videos, they're geared towards beginners. So he takes one pedagogical path, makes it very easy to understand, but he only goes so far because it's a video for beginners. But now you have the same person that now is speaking to a very technical audience on the other range for experts. And so you actually can see the similarities from the same person using the same words, the difference. And so here he'll in this video, he talks about pre-training, supervised fine-tuning, reward modeling, which I just talked about, reinforcement learning. And he provides a lot of context about where these work, how these work, how you go from one to the other. I will be adding these to the book that we have here as a reference. I can tell I still need to work on it. And we'll go through a session on this. But I just wanted to point out that that this is the full end-to-end large language model stack. You can really get a really good sense of this by going just through, honestly, 2 videos on the internet, in my opinion. Just these 2, and you're going to be great at it. The last thing I want to point out is that while you can train a medium-sized language model at home, just like Andre Karpathy does here, just to be completely blunt, you're not going to be able to train a ChatGPT or a Bard level model at home. The compute required for these things is pretty insane. So my suggestion is, if you want to do this hands-on, and we will maybe do this in the next session, go through Andre Karpathy's video. It's going to give you a basics video. It's going to give you a great intuition of what's happening and allow you to then train a medium-sized language model at home to make Shakespeare-like text, just like Romeo and Juliet. And then we can learn about what the big players are doing, because again, these are not things that, like, you will never be able to build a semi-truck at home. You could build a bicycle at home, but this is where we get to the point where it takes a large amount of compute resources and time that you can't do. But it doesn't mean you can't understand them, because the point of this book club is not always to do everything by hand, but at least make sure that you understand all the topics and what's going on. So when you use these products and these models, you're well aware of how they work. So with that, I'll take any questions on particularly pre-training. I can answer what I can answer. I can talk about a little bit about supervised fine-tuning. While I wait for your questions to come in, I'll just talk a little bit about this book club, why I'm taking a little bit of a pause for the next month, and then what I hope to keep going on afterwards. I would love your feedback on the pacing. Sometimes I feel like I'm going maybe too fast. Sometimes I feel like I'm going too slow on the overall structure. I'm right now worried that I'm going a little bit too slow month to month, but I'll let you comment for whoever is here, and I'll talk about what's going on in the next month. So for me in particular, I'm going to Argentina this week. I'm going to be visiting my dear friends, some of that I have never met in person. So I know these great Argentinians and let's say Spaniard who's going to show up as well. But as a lot of you know, I wrote a book with Osvaldo Martin, and I have never met Osvaldo in person. So for one, I'm going to go meet Osvaldo for the first time, and I'm really excited to get to know him. We've worked so many hundreds, maybe even thousands of hours together, and I feel like I've met him, but I haven't actually met him in person. So we have that. But I'm also going to go meet Tomas Capretto, who writes Bambi. So Tomas is a super smart, also Bayesian, that writes one of the best Bayesian libraries out there. A nice entry library to allow you to, well, I shouldn't say entry, but a nice well-packaged library that lets you easily create regression models and more, even now Gaussian processes in PyMC. So I'll get to meet him for the first time. I'm quite excited. If you haven't used Bambi, I encourage you to do so. We've done so in these book clubs before. I'm going to go meet Oriol Abril Pla. Oriol is, here's a picture of him right here. But Oriol, I say his name terrible with a terrible English accent. He has a lot of great stuff about Bayesian modeling, and in particular, he's an expert in model comparison and those topics, and he contributes a lot to all the libraries. So I'm gonna go meet him, and then I'm gonna meet Alex and Dora. Alex creates the Learn Bayesian Statistics podcast, and then I'm gonna meet Martina. I don't remember her last name, so I can't pull her up. I think Martina Catella. She wrote a lot of the docs, and then I'm gonna meet Augustina, who also is another great Bayesian. So I'm going to Argentina. I'm going to meet all these wonderful folks. I'm going to experience the beauty of Argentina. So I won't be able to stream from there because I won't be bringing my setup. That'll be the next 3 weeks. And then more back on top of this, for this book club, is this AI Red Team event at Defcon. So once I come back from Argentina, I will be going to the Defcon in Las Vegas, and I'll be meeting with a lot of AI experts there. There is a large generative red team event, which is going to be testing these models, seeing how they function when they're more adversarially, I don't want to say attacked, but more adversarially tested. And I'm helping run this event with the folks there, providing on-site support and doing a bunch of things with the AI Village team. AI is a particularly important topic. As we know, we're talking about the mechanics of it, but to bring this back to this book club, we try and train. Everybody tries and trains to make these models as useful as possible. Let's say we certainly don't want these models to, create harm or hurt people. I personally haven't met anyone in the AI community that wants these models to harm people. The challenge is, though, is, from the way that they're trained, as we talked about, they can pick up these behaviors from how people interact with them. Famously, there have been chatbots in the past that have learned to be pretty mean because the people interacting with them have trained them to be pretty mean. There's a good example, I think, from Microsoft, where a chatbot learned to be fairly rude because some folks pushed it that way. And it's, the same thing that we have when we try and be people, right? Most parents try and teach their children to be great citizens of society. But, unfortunately, not everyone ends up that way. And with models, the same thing happens. We all want our models. Everyone that's training these models wants them to be useful in some manner or another. But these models can learn bad behaviors because they're learning from humans. A big focus and area of research, and not even just research, just practical day-to-day stuff that's happening, is everyone is learning how to make these models, like I said, beneficial to society. And at the DEF CON AI Village, that's also what's going to be happening. We'll be testing these. We'll say we're going to be crash testing models. Not let me see. You could be crash testing a model at AI Village by showing up to the event, testing it, seeing what it says, and helping improve understanding of how these models work or sometimes don't work. This event, DEF CON, is happening August 10th through 13th. My favorite conference. Actually, it's my favorite conference in the world, more than any even statistics conference, because of just how many things are going to this conference. From AI to lockpicking to so on and so forth. So if you get a chance to attend, I highly encourage you to attend. I will be there that weekend, the 9th through the 10th through the 13th, helping put on this AI portion. When we come back to the next book club, what it means is I'm going to share with you my experience. This again is we're now at the cutting edge of AI. Like actually nobody actually knows what's going to happen at AI Village. A lot of people are holding their breath to see what we learn. We know it's going to go well. Like the event will be smooth, and like the mechanics of the event will go well. But the learnings from it is something that the entire industry is going to be learning all at once. It's the first time this has happened at this scale. It's sponsored by the U.S. White House Office of Technology, and it's going to be a wonderful opportunity to improve our collective human understanding of the computational systems that we're all building together. So coming back to the book club, that's where I'll be the next 4 weeks. I'm going to be in Argentina, visiting some wonderful statisticians that I have not met and have long been overdue to meet. And then I will be spending a week in Las Vegas helping with this event. I will continue trying to write the book in between all of this. I'll have a lot of time on flights and some downtime. So I'm going to write out the supervised fine-tuning section and put some more text and stuff here that we can go through and add some more references. Over the coming months, let's say over the end of September, October, we'll be talking more about things in language models like evaluation, deployment, topics like that, maybe even AI safety, since I'll be talking about that at Defcon. But we'll continue on with this book club, and I'll continue building out our intuition and our knowledge of how these models are built. Because we've covered why they're there. We've covered a little bit of the medium of their structure and how they're trained. Now we're going to talk about how you tune them, just like you tune a semi-truck. We'll talk about how to drive these things, which is called prompt engineering. The infrastructure, like semi-trucks drive on roads. Some bridges can handle the weight of a semi-truck, some bridges can't, and that's an important part of this whole ecosystem, the infrastructure, and then evaluation, right? Even with a truck, you can measure the towing capacity, you can measure the amount of weight it can handle, the fuel mileage, you can measure how comfortable it is, how it looks. There's a lot of dimensions in which you can understand and evaluate something is like a semi-truck. The same thing exists for language models. There's all these things called, like, I think it's called the big bench. So there's the big bench is one of Google's thing. But aside from Google, OpenAI has benchmarks, and these benchmarks are important because these benchmarks help us compare and understand these models. So those are all topics for the future. I plan on continuing this book club and at least coming to you ideally at least once a month with more and more topics. But as always, I would love your feedback on all aspects. I want to put more time into this because I feel like it's important. I'm currently getting distracted, which is a little bit bothering me, but I'm going to keep pushing forward with where I can to try and give you folks, learn with you folks and share what I know. So that's it for today. Let me read the chat and see what's coming in. Tim says Beijing Meetup. That is literally actually what's going to happen in Argentina. We are going to be spending some days together figuring out how we can improve RVs and PyMC for you all. There's also other packages like Preliz, XRA Einstats, Bambi, PyTensor. There are now multiple libraries that the 7 of us contribute to, and we're going to spend some days sitting down, going through issue tickets, trying to figure out how we can make this Bayesian ecosystem particularly useful for you all. So when you folks are doing Bayesian data science or using Bayesian methods, it's very easy for you to go through your priors, get your modeling done, specify your model in a very nice and clean syntax, and evaluate your model with RVs. The same things that happen in large language models. So I'm very excited. And then Yuri says, enjoy Argentina. Hope you do some traveling there as well. Yes, I am mixing it with fun and statistics. I'm just really excited to go to a different country, experience a different culture, try different foods. I'm gonna get to go to different spots in Argentina because the Argentinian Bayesians are all over Argentina. They're not concentrated in one area of the distribution of the country. There's some folks in Buenos Aires. There's some folks sort of more to the west. There's some folks at the south. So I'm gonna try and go to. I'm definitely going to at least 2 spots, and I'm gonna see if I can fit in a third if I can make it all work out. So thank you for the well wishes, and thank you for coming today. I know I scheduled this for you folks with less than a little over 12 hours of notice, so I'm happy that a couple of you could show up. I apologize to the other folks that usually come. I know I probably created a conflict for them, and maybe they gave them a little bit of FOMO. So my apologies. I'm going to Argentina on Thursday, so I wouldn't be able to schedule this the next Sunday, but I'm gonna put the next one on August. I think it's August 20th, somewhere around August 20th. So I will schedule the next session way in advance. I will send out the material way in advance. If there's anything in particular you want to learn, please let me know, because I am definitely going to continue doing this with you all. Even if it takes a bit, I still want to do what I said, which is get you an end-to-end understanding of these large language models. So I don't see anything else in the chat. For the first time ever, we might actually be under an hour, which is amazing. If you need anything, you know where to find me, whether the comments here or on the Discourse. But with that, thank you very much again. I hope you folks enjoy the rest of your Sunday and the upcoming weeks before we get back together in August. All right. See you later.